So today's topic is about the diffraction of the wave and interference, like diffraction and interference together. But to understand the diffraction and interference, it can be explained by two ways. It can be explained by using a concept of a path difference, or it can be explained by using a concept of a phase difference. But we prefer to use a path difference. Path difference is when we use the difference between the two waves in terms of length, and the phase difference is when we take the difference in the two wave in terms of the angle or the way the two waves are vibrating. So if we have two coherent, like if we have a coherent source means every time it is producing a same wave, same phase of a wave is coming out. So example, we have source 1 and we have source 2. Source 1 produces a wave which travel, and this is a point X where we want to identify what is happening at point X. How many wavelengths are traveling from source 1 to X? So 1, 2, 3, and 3.5. So how many wavelengths are there? There are 3.5 wavelengths are traveling from source 1 to X. How many wavelengths are traveling from source 2 to X? So 1, 2, 3, and 3.5. What is the path difference between these two waves? Like difference in the path, difference in terms of the distance covered by these two waves. So this is 3.5 wavelength. This is also 3.5 wavelength. So when I take a difference, so 3.5 minus 3.5. So what is the difference? The difference is 0. So whenever the two waves have a path difference of 0, what type of effect we will see at this point? What kind of, this is an interference. Interference means this is 3.5 wavelength and this is also 3.5 wavelength. When you subtract, you get a path difference of 0. So when you get a path difference of 0, what kind of effect you will see for the wave? You will see that the two waves, crest is joining with the crest. So as a result, what kind of interference will happen here? They will have a constructive interference. When we say constructive interference, it means the effect of the wave will be higher at this point. If these two are the sound waves, then we will hear a loud sound. If these two are the light waves, we'll observe a bright light here, a bright section of a light. So, but what if another point Y is there? And we observe the motion of the wave from the source. So 1, 2, 3, 4, 5. And here from source to 1, 2, 2.5. So what is the path difference here? From source 1 to position Y, how many wavelengths are there? 1 wavelength, 2 wavelengths, 3 wavelengths, 4 wavelengths, and 5. So 5 wavelengths. How many wavelengths are there from source 2 to Y? So 1 wavelength, 2 wavelength, and 2.5 wavelength. So what is the path difference here? So if I work out a path difference here in terms of the wavelength, so 5 wavelengths minus 2.5. So what is the path difference? The path difference is 2.5. So whenever we have a path difference of 2.5, like half wavelength, it means the crest of the one wave is joining with the trough of another. So whenever the path difference is a fraction of the wavelength, like 1 by 2, 1 by 2, 3 by 2, 5 by 2, like 0.5, 1.5, 2.5, 3.5. So what kind of interference we have? We'll have a destructive interference. When we say a destructive interference, what does it mean? If these two are the sound wave, then we will have either a no sound or a very low sound. And if these two are the light waves, then this region will be a dark region because the two light waves are cancelling out the effect of each other. So in short, whenever there is a constructive interference, whenever the two waves meet each other and the interference is a constructive, means they increase the effect of each other. What should be the path difference? The path difference should be a multiple of the wavelength, like it can be 0, it can be 1 wavelength, 2 wavelengths, 3 wavelengths, 4 wavelengths, and so on. But when there is a destructive interference, the two waves cancel out the effect of each other. What should be the path difference? to cancel out the effect of each other. Either it should be lambda by 2, or you can say 0.5 wavelength, or 3 by 2 wavelength, or 1.5 wavelength, you can say 5 by 2 or 2.5, 7 by 2 or 3.5, 9 by 2 or 4.5. So it should be a fraction of the wavelength. Is it clear, the concept of the part difference and the interference? How they are related to each other? Any doubt till this point? Okay. Now, if I say we have a source 1 and the source 2, and there's a screen, or this is a position where we are observing. The two waves from the source travel the same distance. So this is 1, 2, 3, 4 wavelengths. No, for a complete destructive, it should be decimal, like 1.5, 2.5, 3.5. For a complete destructive. If it is like 1.75, so some places there will be constructive, some places destructive. But for a complete destructive, it should be a fraction of the wavelength. 1.5, 2.5, 3.5, and so on. Means half. So how many wavelengths are there from source 1 to this point? So 1, 2, 3, and 4 wavelengths are there. How many wavelengths from source to the point? So 1, 2, 3, and 4. So what is the part difference here? What is the part difference at this point? So part difference at this point, it will be 0. So as the part difference is 0, what kind of interference I will have? A part difference of 0. What kind of interference? So they will have a constructive interference. So as a result of a constructive interference, if these are the sound waves, we'll hear a loud sound. And if these are the light waves, we will observe a bright light here. Whenever the part difference is 0, at a point where we have a part difference 0, what we call that as a central maxima. So this will be a central maxima. Where we have a part difference of 0. Now there will be another point. Example, either above or below the central maxima. As the two waves travel. So this is example 1, 2, 3, and 3.5. And this travel 1, 2, 3, and 4. So one travel 4 wavelengths, like so one is traveling 4 wavelengths, another one is traveling, this is like example 3 wavelengths, and this travel 4 wavelengths. It will be more than 4, but just an example. So what is the part difference here? One is traveling 3.5 wavelength, another one is 4 wavelength. So what is the part difference? The part difference is 0.5 wavelength, or I can say 1 by 2 wavelength, or lambda by 2. So when the part difference is lambda by 2, what will be the interference here? What kind of interference? It will be a destructive interference. So when it's a destructive interference, if it's a sound wave, then there will be no sound. And if it's a light wave, there will be, this region will be a dark. Same way, when we take a distance of the two waves, from this position below the, when we take a distance of this position, so same way, like one wave will travel 4 wavelength. One is traveling, say, let's take 4 wavelengths, another one is traveling 3.5 wavelength. So again, what will be the part difference? The part difference will be 0.5 wavelength. So if the part difference is 0.5 wavelength, again we'll have a destructive interference, or it will region of a dark. So why we call this as a central maxima? Because this is a point where we have a maximum with a part difference of 0, and then as we move up, the part difference start to change. So if we find like this is representing, let's say, a screen, and if it is representing a screen, the center of the screen will be the center of the screen, like we have source 1 and we have source 2. The center of the screen, we will have a maxima. When a center of the screen, we have a maxima, it will be a bright. And what is the part difference? 0. Then above the maxima, we'll have a minima. What will the part difference? 0.5. Then above that, again, we'll have a maximum. What is the part difference? 1 wavelength. Then above that, we'll have a minima. What is the part difference? 1.5 wavelength. Then above the minima, we'll have a maxima, and the part difference will be 2 wavelengths. Same way as it goes down, we'll have a minima, means the part difference will be 0.5. Then maxima, the part difference will be 1 wavelength. Then we'll have a minima, the part difference will be 1.5 wavelength. And then again, maxima, the part difference will be 2 wavelength. So why we call this a central maxima? Because above and below, equal amount of division of a constructive and destructive interference. So this part is a central maxima. So when the wave from the source travel the same distance and the part difference is 0, we will always have a maxima there. And then above and below maxima, we'll have a minima. Then further above minima, we will have a maxima, because the part difference or the distance traveled by the wave is changing when they meet at these points. Is it clear, this idea or a concept of interference and the part difference? Anyone having a doubt or a question till this point? How we know it's a constructive interference? If the part difference is 0, lambda, 2 lambda, 3 lambda, constructive. If the part difference is lambda by 2, 3 by 2 lambda, 5 by 2 lambda, it will be destructive. What is the use of maxima and minima? Using that, we can work out the wavelength. There's a experiment to work out the wavelength of the wave by using these maximas and the minima. So we have a source 1 which is producing a wave in different directions, and we have source 2 which is also producing a wave in different directions. And let's say we have a region where we are observing these two waves. So if it is a light wave, we will have a light sensor. Like we'll have a light sensor or a screen, or if it's a sound wave, we will have a mic there, microphone to detect. So what happened when we compare the distance moved by the wave here and the distance moved by the wave? We observe the two waves combined with each other, and they have a part difference of 0 wavelength. So if the part difference of 0 wavelength, we will have a maxima there. Then the wave from one source and the wave from another source, they combined at this region, they will have a part difference of half wavelength. So we'll have a minima. Then again, the wave from one source at this point and the wave from another source, when they combine, they will have a, like, one might be like example, let's say 5 wavelengths are there, another one is a 4 wavelengths to reach that point. So what is the part difference? The part difference will be 1 wavelength. So if the part difference is 1 wavelength, again we'll have a maxima. Then same way, one is the two waves are traveling and they combine with each other, again we'll have a minima. What does it mean? When the two waves combine, they have a part difference of 1.5 wavelength. and so on. Like when we are going up, it will always be a pattern of a maxima, minima, maxima, minima. Same way when we goes down, we'll also have a pattern of a maxima and minima. Is it clear? Anyone having a doubt or a question? So, so when the wave combine, some region they have a part difference of one wavelength. How we know it's a maxima or the minima? You have to work out the part difference according to the question. So if you have, say, a source 1 is there and you have a source 2, and here is a screen, and the question is you have to identify the what is produced at y. So example 1, 2, 3, 4 and 4.5. 1, 2, 3, 4, 5, 6. So this is 6 wavelength, this is 4.5 wavelength. What is the part difference here? What is the part difference here? So the part difference 6 wavelengths minus 4.5 wavelength. So the part difference is 1.5 wavelength. If the part difference is 1.5, 6 minus 4.5, so 1.5. So if the part difference is 1.5, what kind of interference they will have? They will have a destructive interference. So this will be a minima because of destructive interference. But if I say another point is there, say x, and you want to find what is happening at x. So 1, 2, 3, 4, 5, and example 6 wavelength. And 1, 2, 3, 4, and 5 wavelengths. So 1, 2, 3, 4, and 5 wavelength. So this was 6 wavelength and this is 5 wavelength. So what is the part difference here? The difference in terms of the wavelength. So 6 wavelengths minus 5 wavelengths. So it is 1 wavelength. So if the part difference is 1 wavelength, it means at this point you will have a maxima. So there will be a constructive interference of the two waves. And what about the phase difference? If you remember the phase difference, if I say it's a minima, phase difference without calculation, you can say, yes, the maxima is a constructive and the minima is destructive. What is the phase difference? Because it's a destructive interference, the phase difference of destructive interference is always 180. And if it's a maxima, what is the phase difference? The phase difference will be either 0 or 2 pi. 2 pi radian, 360 degrees. So for a maxima constructive interference, for complete, we are talking about a complete constructive interference or a complete destructive. So for a complete constructive, the phase difference should be 100 and for a complete destructive phase difference 180, and complete constructive phase difference can be 0 or 2 pi radian. This is just a word example to identify, like you have two sources in a ripple tank, two dippers S1 and S2 are vibrating exactly in the same way to produce a wave. The distances are given. The question is interference, destructive or constructive or destructive interference at position X and Y. The wavelength is 2 centimeter. So first we'll find the distance between S1 to X and the distance between S2 to X. What is this distance? So how to work out this distance? If this is 6 and this one is 7, so you use a Pythagoras theorem. Even without calculation, you can also say like this is a hypotenuse here and this one is also a hypotenuse. So in both cases, the wave is traveling a same distance. If this distance is d, this distance will also be d. because both have the same basis and both have the same perpendicular. So it means the hypotenuse will also be same. So if this distance is d, this distance will also be d. So what is the part difference? If I take a part difference, so it will be d minus d. The part difference will be 0. If the part difference is 0, what kind of interference happen at x? Is it a constructive or a destructive? What kind of interference? So part difference is 0. When a part difference is 0, what kind of interference? So it will be a constructive interference. Because whenever a part difference is 0, when phase difference is 0 or a part difference is also 0, constructive interference happen. But what about this position? So this distance is what? 16. And this distance is what? You have to use a Pythagoras theorem to know this distance, because this total is 12 and this is 16. So 12 square plus 16 square in a root. So you got this 20. Because this is a base and perpendicular, we need this distance. So this is 20. When you take 12 square and 16 square in a root. So this distance is 20 and this is 16. So what is the part difference here? So part difference will be 20 minus 16, which is 4 centimeter. One wavelength is 2 centimeter. So 4 centimeter means how many wavelength? So one wavelength is 2 centimeter. So 4 centimeter means how many wavelength? 2 wavelength. So if the part difference is equals to 2 wavelength, what kind of interference? Because 4 centimeter equivalent to 2 wavelength. So if the part difference is 2 wavelength, what kind of interference will happen or occur? Again, there will be a constructive interference at point Y. So both cases, they will have a constructive interference. Is it clear? When it is, no, it is not fraction. When it is like example, if the part difference was exactly lambda by 2, lambda by 4, lambda,